Good evening to everyone. And for this video, I would like to discuss the answers for your homework. I'm very happy that most of you were able to solve the problems correctly, but I would still like to discuss the solutions so that at least for those who were not able to get all the problems, you will have a basis. Okay, so let's start. The first problem in the homework, we are given not P implies not Q and R. So that's the only premise given. And the conclusion is P and Q and R. Of course, for this example, we have no other choice but to work with the only premise given. And since there's only one premise given here, most likely we will not look at the list for our rules of inference, but rather we will look at the list for the rules of replacement because there's only one premise given. And since the proposition inside the sign of grouping is a conditional statement, looking at your rules of replacement, you will find here that we can apply our material implication. And according to the rule for material implication, so let's just review. Material implication states that if we are given P implies Q, that's the second proposition, then that will be equivalent to not P or Q. Thus, if we will now apply material implication from our first premise, we obtain a second premise. So we just get the negation outside the sign of grouping. So we just copy that. We're converting the proposition inside our sign of grouping. So using our material implication, again, for the material implication, we have P implies this entire thing will be represented as Q in our formula. Therefore, this will now be not P or this whole thing is our Q. So we just copy that, not Q and R. So I hope you were able to follow that. Again, we're just using here material implication of premise number one. Again, what's the material implication formula? If we are given P implies Q, this is equivalent to not P or Q. So you will find here that the if clause is negated, the then clause is just copied. The if clause is negated, the then clause is just copied. So we have replaced our first proposition using material implication. Then, what else can we now do? From the resulting proposition, since this whole thing here is preceded by a negation, we can use De Morgan's rule. And the De Morgan's rule states that if your entire proposition is preceded by a negation, we can actually bring in the negation sign, but we have to change the connective from an or that will become an and. Okay, if this is an and, it will become an or. But please take note that the De Morgan rule or the De Morgan's law can only be applied if you have your conjunction and or your disjunction or. So please do not apply your De Morgan's law if you are given a conditional statement. Remember what I've been mentioning in the previous lessons or in the previous lectures. Structurally, your propositions should be the same with your formula. Okay, so this will now become not P and not Q and R. This is using our De Morgan's law in line number 2. Then after using our De Morgan's law in number 2, this will now be a double negation. This will also be a double negation, which now results to P and Q and R, which is the desired conclusion. So this is our double negation for line number 3. So that's the solution for problem number 1. So what will be the emphasis here? Again, as I have mentioned earlier, do not use the De Morgan's rule when you have a conditional statement. The De Morgan's rule or law will be applied if you have a conjunction or a disjunction as a connective. Okay? So that's for homework number 1. Problem number 2 in the homework, we are given the first premise, P or Q implies R and S. That will be the first premise. Second premise is P, and our conclusion is R. Okay, so we need our third premise now. Just a comment from some of your solutions. Many of you jump into the conclusion that you can readily use your modus ponens. So I guess you were tempted to use modus ponens because this is an implication. It's a conditional statement. And then you wanted to isolate R and S because your conclusion is R. So I agree with that. But the issue here is for the modus ponens, if you will recall your modus ponens states that you have P implies Q as your first premise, then P as your second premise, and your conclusion is therefore Q. So you will notice here that for your modus ponens, the first propositions must be exactly the same. The magic word there is exactly the same. Therefore, if you will look at number 2 of your homework, you cannot readily use your modus ponens. Why? Because the first proposition of your first premise is P or Q, while the proposition in the second premise is P. They are not exactly the same. I know that P appears for both, but they are not exactly the same. Therefore, structurally, they are not the same. Therefore, you cannot use modus ponens right away. So what do we need to do? Since you want to use your modus ponens here, we need to produce a P or Q. We are given P. Going to your list, we can actually add P or Q. We're just using addition and based from premise number 2. We added the proposition Q from the given proposition P. Then after doing that, you will now notice that P or Q is already here. And with 1 and 3, you can now use your modus ponens because the first propositions are exactly the same. Therefore, by modus ponens, this will now be R and S. Modus ponens of line 1 and line 3. Then after using modus ponens, our conclusion is R. R is here. This is a conjunction. We need to get rid of S. So we can just disregard S, or we remove S. That will leave us R. And this is now by simplification of line number 4. So that's the solution for number 2. So be careful with your modus ponens. Again, they must be exactly the same. And number 3 of our homework, we have the first premise is P or Q or not R. That's the first premise. Second premise is not P and not Q, with the conclusion not R or S. Not R or S. So many of you were asking, is the third problem in the assignment correct? Because we do not find an S in our premises. Well, that's right. S is not found in our premises, but like what we have done in the previous example, isn't it that if we are given an OR, we can obtain this by having a proposition, let's say not R, and then just adding a proposition, in this case, adding proposition S. Therefore, if you will try to analyze this problem, what we desire to come up with is we need to get another from the two premises and then simply add S to get the final conclusion. Not R is present in the first is present in the first premise. Therefore, we want to get rid of P and Q. We want to get rid of our propositions P and proposition Q. So how do we do that? So what we have here is P or Q. The second proposition, we have not P and not Q. So I guess we can use De Morgan's in premise number 2. And if we will apply De Morgan's in premise number 2, that becomes not of the quantity P. Our N becomes an OR. Then not Q becomes Q. This is using De Morgan's law for line number 2. By the way, every time you prove an identity, please always include the reason and what premise you are applying that rule. Okay? So we now have not P or Q, but this is P or Q. So what can we now use? Since this is an OR, we can use our disjunctive syllogism. If you will recall your disjunctive syllogism, you recall, it's given by P or Q, not P, therefore Q. That's the disjunctive syllogism. If we will use the disjunctive syllogism here, the first premise, this entire thing is our P in the rule. This entire thing here, the not R, is the Q in the rule. So take note of that. This is our P or Q. And we have here not P. It's the negation of the first proposition. Therefore, if we will use the disjunctive syllogism, what will be the conclusion? It is simply the second proposition. Right? It's just the second proposition. Therefore, naturally, if you will use 1 and 3, we can have syllogism. Isn't it that we have P or Q here? This is not P or Q. Therefore, our conclusion is not R, using disjunctive syllogism. disjunctive syllogism of line number 1 and line number 3. And finally, since we already have not R given here, we need, in the conclusion, not R or S. So we have not R or S. This is just by using addition based from line number 4. Obtaining now our desired conclusion, not R or S. So there you have it, the 3 problems in your homework. And for the next video, I will be introducing another rule. We will be adding another rule. So coming up is the next rule.